Previously in this module we have worked with the client object model and site and web objects, but now it's time to delve into retrieving data with the client object model. So let's step through this first sample. As in the previous demos, we create a client context object, and in its constructor we pass in a string that indicates the site to connect to in SharePoint. So in this case we are retrieving that from a text box called site URL, and that's in our application. We then instantiate a web object and set it equal to the web property of the client context, just as before. And furthermore, we call load, and we load the web object. However, this time we also call load for the lists property collection of the web object, and this will allow us to start working with those lists. Additionally, when we call load for the web object, we can also provide a lambda expression, and our lambda expression filters the lists to only retrieve those where the title is not null. So that's a very important point. You can use lambda expressions in these load calls. We then make a call to execute query, which takes these previous commands and batches them and sends them to the server where they will be executed. And what that really means for us is that we have access to the lists and web objects that we have been instantiating and calling load methods for. In our application, we have the list box called all lists, so we will clear its items with alllists.items.clear. And then we will iterate through the lists collection of the web object and populate the list box with the default URL and title of the lists. In the next sample we actually start working with data, and the sample comes from a Silverlight application. We'll see that Silverlight application in a later demo. But first of all we have the client context object, and we have a list object called docs. And just for use in our code later on, we have an integer value called file tracker. Now as the Silverlight application loads, we work with the client context object again. This time in its constructor we pass in the URL for the current application context. So we are assuming that this Silverlight application is running in a SharePoint site. We then perform some very similar operations to that which we've seen before. We call load for the web and load for the lists collection. This time however we get a reference to a specific list, and we can do that in a number of ways. But in this example we call getByTitle, and this is a method of the lists collection, and we pass in the name of the document library or list that we want to retrieve. We then load that document library, and we are loading a specific instance of the list now, and we obtain or load the root folder and the root folder's files collection. Now because we're working in Silverlight we have to call execute query async if we're working on the main UI thread, so we're not allowed to block the main UI thread with synchronous query calls. So we call execute query async, and we pass in our own event receiver, or in fact our callback function, for the event to fire when the execute query async is completed. So in this case load site data fires when the callback is received. Now what that event procedure does is to switch the context back to the main UI thread, and this is so we can update the UI. So we call dispatcher.beginInvoke, and we pass in one of our own methods, and our own method is called addFiles. This is important, so we are now back on the main UI thread, and we can start iterating through the files collection of the root folder of the document library, and we can start loading individual files in the UI. Now again, because we want to get some properties of the file, we have to call execute query async again, but again we're on the main UI thread, so we have to call execute query async. And we will provide another event handler as a callback, and this time we'll call that addFileToUI, and that callback method runs when the execute query async has successfully completed. Out of interest, the second parameter of null is a delegate for perhaps another event procedure that may fire if the request does not succeed. So in our case we're assuming that this will succeed, and so again we will call dispatcher.beginInvoke, and the dispatcher switches our context back to the main UI thread, and we can start working with the user interface and those file objects. So we can add files to our stack panel, and we have a stack panel called file wall, so we can extract each of these files, its name and its server relative URL, and we can start building up the UI components such as hyperlink buttons. So we will build a hyperlink button called FileLink, and we will set its contents equal to the name of the file, and we will set its navigate URI to the server relative URL of the file. We will add those up to our stack panel, and the reason we use our integer value for file tracker is that we can use it to determine whether we've rendered all files.